Oh, hey there. Guess what we're ready for? We are ready for page 15 in your math binder. Today we are going to take all those things we were looking at with multiplication and with integers, this idea of same signs, positive product, different signs, negative product. We're going to bring that into play with rational numbers because, of course, as we now know, rational numbers are more than just integers. Integers count because they can be written in the form of a over b. 5 can be written as 5 over 1. Negative 2 can be written as negative 2.0. However, we need to expand that to all rational numbers. And as an added bonus, we're also going to see how the standard we finished before last week, conversions, we're going to see how that's going to become really useful for us in doing these calculations more efficiently and more accurately. So you've got page 15 in front of you, you've got pens or pencils in hand, and you are ready to go. Check out this problem on the top. It says you need to buy 3 3/4 yards of fabric for a Halloween costume you want to make. Good timing for that. Each yard of fabric costs $2.50. How much will the fabric cost you before tax? We'll learn a little bit later this year how to calculate things like tax. But for right now, we're just going to worry about before tax, what will this cost you? Do you recognize that this is a multiplication problem? One key word in here that tells me I'm going to multiply is the word each. This word is telling me that this is really $2.50. Here's another way you could say this. The cost of this fabric is $2.50 per yard. And you might remember from elementary, and if you don't remember that, you're going to hear that word per and learn so much more about that word per this year in 7th grade. But when you see this word per, that is a clue to you that it costs this for every single yard or each yard. And that is a tip that this is a multiplication problem. And I am going to show you, first let's write this. If it is $2.50 per yard, that means I need to do $2.50 times the number of yards. And one of the things we worked on last week was this idea that rational numbers can be written in many different forms. And this shows you a very good example of why you need to have that understanding. As this is written right now, I can't really calculate it like that. I've got a decimal and I've got a fraction. And in order to complete this mathematics, I need those to be in the same form. So actually what I'm going to do, and we'll practice this a lot over the next couple of days, what I'm going to do is draw a line here because we are actually going to calculate this in 2 different ways. This is one of those common conversions from your chart, 3/4. Take a second right now and go ahead and look it up. Or you can type in your calculator 3 divided by 4. Or maybe this is one that you have memorized right now. That would be even better because every time you type it in, every time you look it up, 3/4 is the same as 0.75. So if it's 3 3/4, I'm going to change this. I'm going to write this one on top. I'm going to write 3.75 times, and just by way of reminder, when you are multiplying, I'm actually going to put 2.5. You want to take off any extra zeros at the end there because they will just make more place values for you. And I want you to notice also here, first review, first reminder, that I did not line up place values because I don't need to line up place values because I'm not adding. Okay, I'm going to say that again. Because I'm multiplying, I do not need to line up the decimals. Okay, because I'm not going straight down, I'm going to multiply through the place values anyway, and then I will remind you at the end how we decide where that decimal goes. So today we are reviewing decimals, so the first way we're going to do this is with decimals. Multiplication, we already reviewed addition, line up the decimal. Multiplication, you don't have to. So we're going to start like this, 5 times 5 is 25, carry the 2, 5 times 7 is 35, 36, 37, carry the 3, 5 times 3 is 15, 16, 17, 18. I'm not going to do any decimals yet. This is a review. Then before I take that 2 through, I'm going to put a 0 placeholder. And I'm going to go 2 times 5 is 10. Now I'm carrying a 1. 2 times 7 is 14, plus 1 is 15. Carry the 1. 2 times 3 is 6, plus 1 is 7. Now I'm going to add those. 5 plus 0, 7 plus 0, 8 plus 5, 8, 9, 10, 11, 12, 13. Using your fingers is always good. Carry the 1, 7, 8, 9. Now, obviously, that's not the correct answer. That is very expensive fabric. So the other thing I want to remind you of is that when multiplying a decimal, however many place values were in the total problem, so this one had 1, 2, 3, then I move it 1, 2, 3 places in and the decimal goes right there. So rounded, because money doesn't go out to the thousandths place, and what they'll do is round it. Because the next number is a 5, this 7 bumps up to an 8. Remember that from all the way back in 5th grade, rounding? Whatever number you're trying to round, look at the number after it. There's only 2 options here. This 7 is either going to stay a 7 or it's going to bump up to an 8. Those are the only 2 options. It never goes down. It either stays or bumps up. And you look at the number after. If it's a 5 or higher, bump it up. If it's below, leave it alone. So this tells me the cost would be $9.38. Now, just to be doubly sure, I also have a calculator here. That's the nice by hand review of how it works. If I'm typing in a calculator, 3.75 times 2.5, and you can put the 0 or not, doesn't matter. There it is, 9.375, which rounds up to $9.38. Notice my calculator didn't round for me because my calculator doesn't know that I'm dealing with money. My brain knows that I'm dealing with money, and so I have to apply it to what makes sense. All right, now, what if instead, let's just show ourselves one more way. What if instead I remember things like 0.50 is the same thing as 2.5? Do you guys remember that? 0.50, 0.50 is always 1/2. If it works that way, that 1 divided by 2 is 0.5, then it also works to change it back. 0.5 is 1/2. So I can also work this. Let's take this opportunity right now to review how fractions work. Do I need a common denominator to multiply fractions? No, you do not. You can get a common denominator, but actually that will make the process much longer and make much more simplifying for you. You do not need a common denominator when multiplying fractions. What you do want to do is turn them into improper fractions. Fractional form, A over B. Not mixed number, but total fractional form. That goes like this. 2 times 2 is 4, plus 1 is 5. This will be a very important skill as we move forward. Remember I had to do a practice quiz called Fraction Basics a little while back? That's why we were reviewing it, because it comes into play big time here. Let's do this one. Ready? Here we go again. And please make sure you are writing all of this down with me. 3 times 4 is 12. 12 plus 3, 12, 13, 14, 15 over 4. Now, I want to refresh your memories on something else here. It is called cross-simplifying. That's not the same as cross-multiplying. That's something that we'll definitely get to later in the school year. Cross-simplifying is where you look and you say, can I simplify anything? Okay, you look numerator and denominator, 5 and 2. Do they have any common factors? No. 15 and 4, do they have any common factors? No. And then you can also look this way, which actually in this case, none of them do. So remember to multiply fractions, you simply multiply across the top. 5 times 15 is 75. Multiply across the bottom. 2 times 4 is 8. Hey, check this out. Are you ready? Guess what I'm going to type in my calculator right now? I'm going to convert this to a decimal now. 75 divided by 8. Can you guess what it's going to say? 9.375, because of course it is the exact same answer as this one, because it's the same numbers, just written in different forms. So this answer is still $9.38. So you can change it to decimals and work with it in decimals throughout, or you can change it all to fractions and work with it in fractions and then change it to a decimal at the end, only because we were dealing with money. You don't always have to change it to a decimal. But the fact is, for many problems, it can be worked equally well in either form. Sometimes, though, on other problems, one form works better than another. So let's refresh our memories. I'm going to keep going with two different ways on some of these. Like this one. I can do you remember you can write -3/1 times 3/4? This one, if it's already a fraction and I don't see a decimal, I'm just going to keep it in fractions and keep working with it that way. The only real way I convert is if it's a mix. If I have a fraction and a decimal, then I have to decide to convert something. But this, it was already fractions, so I'm just going to keep it that way. I'm going to multiply across the top. 3 times 3 is 9. 1 times 4 is 4. Do not forget, let's actually make a little note to ourselves so that we don't forget. I still need to follow the rules. I'm going to draw an arrow over here and I'm going to remind myself different signs means negative product. The more you write these things, the more you say these things, even if you talk to yourself a little bit through these math videos, that's okay. I won't think you're crazy. I'll think that you're smarter because you really want these things to stick in your brain. So we cannot forget that. And what that means is this answer here is not 9/4, it is -9/4. And you can totally leave it like that, or you could write it as -2 1/4, which also, guess what? If I type in my calculator 9 divided by 4, it's of course 2.25 because that's the decimal equivalent of this answer. For a lot of stuff that we do, it won't matter to me whether you work in a fraction or a decimal. Sometimes though, like number 2, you definitely wouldn't want to change those to decimals because guess what 2/3 is? 2 divided by 3 is 0.6 repeating. Repeating decimals don't work nicely in by hand calculations. And in this case anyway, they're already fractions, so I'm just going to leave them fractions and go with it. I'm going to rewrite it down here so I can see it a little bit better. And then how do I do this? Ooh, hey, check this out. This one, I could simplify first. Actually, you know what? I'm going to show you something first. If I go across, 1 times 2 is 2. 2 times 3 is 6. This, I'm going to circle this with my pink pen. And I'm going to tell myself right here, same signs, positive product. Whether you're dealing with fractions, decimals, integers, all the rational numbers have those same rules. Same signs positive, different signs negative. So I already saw negative times negative is positive, but I also know that 1/6 simplifies to 1/3. And I'm going to tell you right now, if you don't simplify your answers before you type them into Canvas, you will get them wrong. So watch that really closely. You must simplify everything. It's not necessarily going to say that in the instructions because this is something you've done since 4th grade. So at this point in 7th grade, you should just always assume I should simplify things. I should always simplify. Now, the thing I was going to show you here too is that you could simplify right here. This is what we mean by cross simplifying. If I see, hey, divide by 2, divide by 2, then when I do my multiplication, I could skip this part and it would go right to 1 times 1 is 1, 1 times 3 is 3. We'll practice that a little bit more as we go because cross-simplifying really does save you a lot of big simplifying at the end, okay? All right, moving right along here. I'm going to talk you through 3 and 4, and then I'm going to let you try some more of them, okay? In a problem like this, I have a fraction and I have a decimal. So then the question is, do I keep the decimal and change that to a decimal? Do I keep the fraction and change that to a fraction? Well, really, you could go either way. This one's not so bad. And with decimals, as I work through them, if you type some decimals in a calculator, that's really okay instead of doing it out by hand up here. But show me what you're calculating. So I could either change this, 3/4 is 0.75, and I could do it like this. Or, let me show you another option. Or you could leave 3/4 as 3/4, and then maybe you have memorized that 0.25 is 1/4. Maybe. Now, which one of these, people often talk about fractions like they just really don't like fractions. But let me just ask you, which one of these do you think is easier to do by hand? Because I would actually argue this one is easier to do by hand, because all I have to do is multiply across. 3 times 1 is 3, 4 times 4 is 16, and I got 3/16. This one, to do this by hand, I have to do a lot more. 5 times 5 is 25, 35, 36, 37. That's 5 times 0, that's a 3, and then a 0 placeholder, and then 2 times 5 is 10, and 14 and 15, and I hope I'm not making any mistakes here. And then I gotta go 5, 7, 8. I just added those, and then I go 1, 2, 3, 4 place values takes me all the way to there. Do you know what I'm gonna do to find out if I did all that right? And I did that really fast, and you might have needed to slow it down a little bit. But I would argue in this case, the fractions were actually a lot easier to do by hand. So don't be hating on fractions all the time. Sometimes they're a lot easier. Let's double check. If I type in here, 3 divided by 16. Oop, there's that decimal. Or if I type in 0.75 times 0.25, there we are. So 2 different processes, but the exact same answer. They look different, but they're actually the same answer. And you can make a note to yourself over here just in case you forgot this or you forgot why. Right here, 0.25. Remember, this is all about place value. Do you remember how that's the hundredths place? So I put 25 over 100, and that simplifies all the way down to 1/4. That's why that decimal turns into that fraction. But if you just get some of them memorized, I promise your life will be easier. Okay? All right, one more I'm going to do with you here. 1/3 does not change to a decimal nicely. Go ahead, type in your calculator 1 divided by 3. We know that one, but that's not easy to work with by hand. So I'm going to stick with fractions here, and I'm just going to put -2 over 1. Then all I have to do is multiply across the top, multiply, almost said multiply across the bottom. That doesn't simplify, and we're done. Why did I make the answer negative? Because different signs, the product is negative. Why did I do that? Different signs, the product is negative. And just kidding, I'm just gonna keep helping you. You ready? Let's keep going. This is not a handy dandy one that I have memorized, so I'm going to leave that fraction. 0.5, let's make this note over here. Here we go. 0.5 is always 5 out of 10, which is always 1/2. 0.5 always equals 1/2. So guess what? If I see 3.5, you know what I'm going to do? I'm going to write 3.5. Right away, if I see 0.5, it adds a half to it every time. 4.5, 4.5, 7.5, 7.5, 12.5, 12.5. You get the idea? So I'm timesing that by -8 over 21. Now I can't multiply these until I make this improper. So 3 times 2 is 6, plus 1 is 7. And you can do the parentheses or you can just do a times, whatever's easier for you to work with. Okay, watch this. You with me? Here I go. Divide by 7, divide by 7. Do we all understand why I could do that? I could do that. It's called cross-simplifying. I could do that because they both had a factor of 7. These both have a factor of 2. So I'm going to divide them both by 2. It's important that you divide them both by the same number. Divide by 2, divide by 2. And don't forget about this negative right here. So that immediately tells me different signs, the product is negative. So I'm just going to deal with that right now so I don't have a chance to forget it. Different signs, the product is negative. Now I'm just going to multiply these orange numbers instead of the purple ones. And I know my simplifying is already done. 1 times 4 is 4. 1 times 3 is 3. Ta-da! That's it. Okay, I'm going to take you through a think aloud on the rest of these problems. That means I'm going to show you what I'm doing, and you're going to listen and write. You're also going to listen as you write because I'm going to say out loud my thought process. Here we go. I'm going to make negative 1.5 improper. 1 times 2 is 2 plus 1 is 3, and then I am not going to forget that that's negative. I know the parentheses right next to it means I'm multiplying, so I'm going to write negative 6 over 1. This is subtraction. So you know what I'm going to write? Plus negative 4, because we can't forget all the stuff we've already learned. That's coming back in a big way here. Plus negative 4. Okay, here's what I'm going to do now. Divide by 2. Divide by 2. I'm not doing anything with that though, because that's not even multiplying. I'll deal with that in a minute. Now this is a negative times a negative, which is a positive. A negative times negative is a positive. Negative 3 times negative 3 is positive 9 over 1. Oh, I don't really need to write the over 1. That made it a whole number. So this is really 9 plus negative 4. Switch your brain back to addition rules. Different signs subtract. Take the sign of the one that goes farther. We did it. Last two. Here we go. You still with me? You still writing things? You still listening? Okay. I see 2 fractions and a decimal. I'm going to keep these fractions and I'm going to change that to a fraction. I know that one. It's negative 1/4. If I have 3 fractions and it's all multiplication, that's okay. I just multiply across the top. Be careful with your signs. Watch this. Negative 1 times negative 1 is positive 1. But then that positive 1 times another negative 1 makes this whole thing negative again. So I know this is all negative. 1 times 1 times 1, 1. 2 times 4 is 8. Times 4 is 32. Or if you go this way, 4 times 4 is 16. 16 times 2 is 32. No matter how you look at it, you get a 32 in the denominator. And why is it negative? Because a negative times a negative makes a positive product, but then a positive product times a negative product makes it negative again. Okay, last one. Here we go. You're doing great. Stay with me. Write it down. What is that going to become? Oh, I know. It goes to the tenths place, so it's negative 3/10. Plus, we wrote some stuff down like that on our conversion chart. Use that little chart for as many of these as you need to change them. And I did that because this would not turn into a nice decimal. So I'm going to times by 10/3. That's addition, so I'm going to write it, but I'm going to deal with it later. Watch this. Divide by 3, divide by 3. Divide by 10, divide by 10. Different signs, the product is negative. All of that turned into negative 1. That was pretty cool and pretty handy, and changing it to fractions helped me see that really quickly. Don't hate on fractions. Now I have this. Now I switch my brain back to addition rules and I say, same signs add, keep the common sign. Check that out, using our new math with our old math and putting it all together. All right, you're going to practice some of this. If you have any questions or struggles or concerns, please let me know. And remember, on your practices, you can try them multiple times. So if you don't get a good score, try to figure out why and give it another go.